So we have looked at local area networks, and then we have looked at how to extend these local area networks via switches. In this video, we will look at how to impose multiple virtual LANs on a single physical extended LAN. This is how a typical configuration looks in a building. So there are multiple computers within a floor. You hook up all these computers via a switch. Same thing at the second floor, you again hook up all the computers via a switch. Same again in the first floor. And then you are going to interconnect these switches. And finally, you connect a router to one of these switches, and thereby you can access the internet. Suppose if this were an office building, what is also shown are the computers and which department they belong to. For example, the green computers belong to management, the blue computers belong to accounts, and the yellow computers belong to sales, and the purple belong to R&D. So do you see any issues with this configuration? The biggest problem with this configuration is what we term lack of traffic isolation. So what does it mean? Suppose this computer were to send a broadcast packet. Because of this extended LAN operation, this broadcast packet would be received by every other computer within this particular extended LAN. Well, you may think, what is the big deal? The big deal is that this can lead to scalability problems or performance problems because this broadcast traffic is going to eat into your bandwidth. Imagine a very large extended LAN where there are too many hosts and each of them are sending broadcast traffic. A lot of bandwidth is going to be consumed in serving this broadcast traffic. But more than performance, what is of even more importance is security concerns. Often these management group does not want any traffic that they exchange to be snooped by other departments. The same goes likely for other departments as well. By the way, switching by itself does provide some security. In other words, if this guy has a packet to send, let me call him A, has a packet to send to B, if the switch has learned where B is, it takes in and sends it out only on this interface. For example, these two are not going to receive this particular packet. But on the other hand, if the switch has not learned where B was, it is going to flood the entire network. But people are paranoid in that they don't want any traffic belonging to a specific group to go to any other group within the extended LAN. So how would you solve this problem of providing traffic isolation? How would you reconfigure these computers so that you can provide traffic isolation? Actually, it's not so complicated. All you need to do is, for a given floor, you connect each group to a switch and you interconnect these switches via router. What do I mean by this? For example, you look at floor 3. So these are the management M1, M2. You're connecting it to a switch. Similarly, floor 1, there is only one guy, management guy. So again, you connect it to a switch. You may want to interconnect these two switches. And again, floor 3, there are two accounts guy. Floor 2, there is two account guys. Floor 1, there is an account guy. So again, you interconnect them via switching. Now, these two groups, you are now going to connect them via a router. A router, because it operates at the network layer, is going to provide isolation between these two groups. Are we done? No, we still didn't cover virtual LANs. So what is the problem with this particular approach? Well, in this modified configuration, you have more issues. So one, we are using too many switches. The problem number 2 is, for a given switch, you are using very few ports of that particular switch because there are very few users connected to that particular switch. So this is going to increase your overall cost. Not just this, there is another problem related to user management. Suppose this employee corresponding to this A5 who is part of accounts now has become part of management. Now, in order to convert this, you basically need to connect this computer to some switch here. So basically this means the physical cabling has to be changed to reflect the changed user groups. So you want to avoid all this. So what is the solution? Enter the hero, virtual LANs. So virtual local area networks basically partition an extended LAN into several seemingly separated LANs. So they impose a logical topology in software without the need for rewiring, that is the physical change of cable. Now VLANs can be defined in several ways. There are port-based VLANs, MAC address-based VLANs, and even network protocol-based VLANs. In this video, we will look at only port-based VLANs because some of these things are a bit more complicated. So what are your thoughts on how you could implement a virtual LAN on an extended LAN? So in port-based VLANs, basically the ports of a switch are divided into groups. So for example, this is a 16-port switch indicated by these numbers 1 to 16. And the ports of the switch are divided into two groups here. It could be divided into more groups as well, depending upon how many VLANs you want. We often refer to a group by colors. So in this case, this group belonging to management is represented by the green color and by accounts by the blue color. Now each group is going to constitute a VLAN. So if you are an intelligent switch, which this VLAN switch is, you can potentially ensure that the broadcast traffic from one group does not reach the other group. What do I mean by this? For example, if 3 were to send a broadcast packet, now this switch knows that this port, this 2, 4, 5, 6, 7, 8 belong to this particular group. So it is going to forward this broadcast packet on each of those lines. Okay, it will send them out on all these ports. But it will not send them on any of these other ports because they don't belong to this particular group. Similarly, if this guy were to send a broadcast packet, it will send out on all ports belonging to the same color. It will not send it out on ports belonging to the other color. Now, does it solve the issues we have talked about earlier? Yes, it does provide traffic isolation. As I mentioned, broadcast traffic is sent only to all the nodes belonging to that particular group. It is not being sent to this other group. Cost, earlier we had to use so many switches, but here we just used one switch to connect all these users. And again, user management is not a big deal because all you need to do is you need to reconfigure the VLAN software so that the port reflects the right color. So for example, earlier this belonged to blue. Now this guy has gone to management, so you are just changing the color of this port to green. Thereby, if this guy were to send a packet, apart from sending it to all these, it is also going to send it out on this particular port. A nifty little idea, but there is some issue with this still. Can you think of what it is? Suppose 3, in other words, the user connected on this port 3, let me call it U3, wants to send a unicast packet to user 13, which is belonging to this other group. Now, how does this routing happen? So we are looking at the problem of how to route traffic from a management group to the accounts group, since they are completely isolated as far as the switch is concerned. So the solution is again straightforward. You can connect them via router just like you connect separate switches. So there is some switches that are forming an extended LAN serving some group, and there's some other switches forming an extended LAN serving some other group. So this is group 1, this is group 2. If you want to interconnect the groups, you need to use a router. That way, the domains are isolated from each other. In other words, broadcast traffic here is contained within this group. It doesn't go in here. Whereas, if you want to send packets to the other group, the router is going to handle it for you. That is at the network layer. Now you will say, what? I have to invest in another router? So just to address that, a lot of these vendors of VLAN switches often include this router functionality as part of the VLAN switch itself. So you don't need an external router. The router functionality is implemented as part of this VLAN switch itself. Nope, we are not done still. There are more issues. Suppose you have two switches, switch 1 and switch 2. So the switch 1 has some management group, this accounts group. Similarly, switch 2 also has some management and net account groups. Now, how do you interconnect these switches such that you can still provide traffic isolation? Some of you may have thought of this. I have these two empty ports on the switch and similarly two empty ports on this other switch. So what I will do is I will assign this empty port color green, and similarly this also color green, and I'm going to connect them up. Similarly, I'll assign color blue and color blue to these two empty ports, and similarly I'm going to hook them up. Now suppose 3 were to send a broadcast packet, what is going to happen? You will deliver it on all these ports, but apart from this, because this is also labeled as green, you will deliver on this port. So the packet will come via this wire in here, and this, once it comes here, it is going to deliver it out onto all these other ports. So it's as if some user connected to this port 1 has actually generated. It turns out to be it has come from the other switch, but we could view it as some user connected to this port has generated, and thereby it will forward it out onto all these other green labeled ports. Now are we done? Not yet still. There is still a problem with this particular approach. What is it? Well, this solution is not scalable. For example, if there were n VLANs on each switch, how many ports per switch do you require? Assume there are 2 switches you want to interconnect, and on each switch there are n VLANs. So basically you will need n ports, 1 port for each VLAN. So for example, in this case you had identified this port 1 for green and port 16 for blue, and similarly on the switch also you had to identify this port 1 for green and this port 15 for blue, and thereby interconnect. So there is something called VLAN trunking that is used to overcome this scalability issue. So what happens here is that a special port on each switch is configured as a trunk port. So in this case, let's stick with 16 and 15. These are the trunk ports. Now these trunk ports are going to belong to all VLANs. In other words, the color that is assigned to this in this particular case would be both green and blue. Whereas if there are more VLANs, whatever colors correspond with the VLANs, all of them will be assigned to this particular port. Now frames sent to any VLAN are forwarded over the trunk port and reach the other switch. So for example, again, if 3 were to send a packet, all these ports will receive it naturally. Apart from this, because this also has the color green, you're going to send the packet out into here. So the packet or the frame is going to reach the other switch. Something must be nagging you now. What is it? Now let's say there is a frame that is received on this particular port. Now this frame, should I send it to this green guys or should I send it to the blue guys? How do I figure that out? So the solution for that is the frame needs to identify the VLAN for which this particular frame is destined to. So the frame now needs to carry this additional information. So this is defined by the 802.1q protocol. So basically what you do is you add a 4-byte VLAN tag into the header. By the way, this is done by the sending switch, and as soon as this packet comes, the receiver switch will look at the tag and remove it before forwarding it to the other ports. That way this is transparent to the clients. The clients don't have to understand this VLAN tag. They will receive a regular packet. Now we are done, but only with port based VLANs. The others we are not going to cover based on MAC address or protocol based. So to summarize, extended LANs are nice in that they interconnect a lot of individual LAN segments, but they suffer from the problem of traffic isolation. VLANs are an interesting concept that partition an extended LAN into several virtual LANs. You could do this based on ports, MAC addresses or network protocols. What we have covered is port-based VLANs where they assign colors to the ports to aid in frame forwarding. VLAN trunking is a solution that helps interconnect switches in a scalable fashion.